So in this video, we are on page 14, and on page 14, we are investigating the role of the constant in our additive relationships, all right? I wanted to remind you guys in a previous video, you saw a proportional relationship up here with a coefficient, but below you saw an additive graph with a constant, and I mentioned that we would start to explore the role of this constant in the graph. So here we are on page 14, and the first thing that I wanted to throw out there is that this first graph, this equation, y equals x, this is something called the parent graph. The reason this is called the parent graph is because it's the graph where all other graphs come from. So in this one, the basic graph, we have 1 times x is just x, and when you add 0 to that, we can get rid of the 1 and the 0, and we don't need the 1 and we don't need the 0, and that's why we're left with just y equals x. So it can't get any more basic than multiplying by 1 to not change anything and adding 0 to not change anything. So again, this is the parent graph, and the way it works is if x is -2, so is y. It literally says y equals x. So whatever I have for x, that's what y equals, and then I took those points and plotted them here, and that's the first thing I want you guys to do, is I want you to fill out this table of values, and then I want you to plot these points, and with a ruler, I want you to connect, and I want you to go ahead and have your parent graph on your coordinate plane. That's the very first thing I want you to do. Pause the video if you need to pause the video, but that's the first thing I want you to do before we start looking at part B, okay? Now for part B, you'll notice that the constant is changing to a +1. So your goal is to see if you can figure out what this +1 is going to do to my red line. Now I already filled out the table of values here. I just am adding 1 to all of these, and now when I plot, I've got back 2, down 1, I've got back 1, 0, 0, 1. We're going to go over 1, up 2, and the last one over 2, up 3. I'm going to change the color of this to be blue so that it all lines up. And when you get this one connected with a straight line, you should notice a couple of things, okay? First thing you should notice is that it's parallel. These are parallel lines, and it's because they have the same rate of change. It's actually the 1 that's the coefficient. That's the reason that they're parallel, but we'll continue to develop that later. What I want you to focus on is what happened to the red line. Do you see that the red line simply moved up 1 spot? If I were to take this red line and move it up, that is now the blue line. So when the constant goes from a 0 to a 1, you'll see that it moved the line up 1 space, all right? Now you can make a prediction here about what this is going to do when you see this +2. You can make a prediction about what would happen from the original red graph to this one. All I did here was take the -2 and added 2, +2, +2, +2, +2, and that's how I got this range. So now let's plot these points. We're going to move back 2 and then don't go up or down any. We've got -1, 1, so I'm going to go back 1, up 1. We've got 0, 2. We've got 1, 3. And we've got the last point we're going to plot is 2, 4. So now this line will be in green so that it stands out. All right, and when we connect here, there is, once again, a parallel line because it's still just regular x, y equals x. But then this time, since it was x +2, you'll notice the original red line has moved up 1, 2 spaces. So all we're saying right now, folks, is that the constant will move this parent graph up if it's a positive constant, okay? Now down below here, we've got some negatives. We've got y equals x -1, then x -2, and then x -3, all right? So if the positive constant moved it up, you can make a prediction for what's going to happen here with the negative. Now again, first thing I did was fill out the table of values, and I simply took away 1. So -2 minus 1, then I did -1, -1, -1, -1. All right, so now we're going to plot these in purple. So I'm going to move over 2, down 3. That's the first point. Then I'm going to move over 1, down 2. Or, excuse me, I'm going the wrong way. I didn't catch that. I should be going back 2, down 3. So sorry about that. From the origin, I'm going back 2, down 3. And that's going to be right here. All right, then I need to go back 1, down 2. So back 1, down 2. 0, then down 1, over 1, then I don't move up or down any, and then the last point is going to be over 2, up 1. So we can see here, my purple line, it's the exact same as the red parent graph. The only thing that changed is I moved the whole line simply down a spot. Okay? So you'll see that on this page, all of these lines should be parallel, and they're all parallel because they all have this 1x. 1x. Down here, we still have 1x, we still have 1x, we still have 1x. So that's why these are all parallel, and the focus of this video is the fact that here, when this is now a minus 1, the red line simply moved down 1, okay? Now here's something else that I want to go ahead and point out. I'm going to highlight it here in, let's go with this blue color. And I want to point out here that it crosses at the origin, and there it is. When that line moved up one spot, there it is, and there's that point in blue. Then this one moved the red line up 2 spaces, and there's the 0, 2. So if the next one moved it down 1, we should see a 0, negative 1, and there it is. If this is a constant of negative 2, it should be 0, negative 2, there it is. And when this one's a negative 3, it should be negative 3. So now what I can do is I can say, okay, so if I'm looking at graph E, it's just x minus 2. I know it's going to cross right here. All right, and then I'm going to keep it in line with the other ones. This is just the up 1 over 1. This is my little staircase. And of course, obviously, I can just plot all of these points, and you can see here that we have this black line. And I can extend it so it goes all the way. That's no problem. And so the y equals x minus 2 is down here at negative 2. You'll see that ordered pair is 0, negative 2. So for the last one here, when it's going to be x minus 3, all I did was subtract 3 from all of these values. So negative 2 minus 3, minus 3, minus 3, minus 3, minus 3. Now let's come through here and let's see, let's go with orange. And we're going to plot back 2. Down 5. Let me get rid of that. There we go. Back 2, down 5. Now I'm going to move from the origin, back 1, down 4, 0, down 3, over 1, down 2, and over 2, down 1. And let me make this an orange line just so it'll stand out. And we are good to go here. Make sure you're using a ruler to connect your dots, folks. And then we'll have here the orange arrow. And so let me come up here, boom, boom. So what this video is meant to kind of point out is that the constant will tell you where the line is going to cross the y-axis. That is literally the huge, big, now main takeaway, that this is our y-axis. And what we can see here is that the plus 0, plus 1, plus 2. There's the 0, plus 1, plus 2. Down here, we have our negative 1, negative 2, negative 3. So there's the negative 1, negative 2, negative 3. So the constant tells us where the line will cross the y-axis, okay? So down here, let's sum up. Y equals x plus b, okay? This represents additive relationships, where the coefficient of x is always 1. We talked about that here, 1 times x. There was 1 for all of them. And this is the big part. The constant represents the point where the line crosses the y-axis, okay? So if you were to see the equation y equals x plus 8, you should immediately be able to tell me that this thing is going to cross at 8. So the ordered pair would be 0, 8, and it would be way up here somewhere at 0, 8, okay? That's the first main thing I care that you can tell me. All right, the other thing I wanted to point out here is that the constant could be negative, because when you add a negative, you're subtracting. So right here, this constant, technically we're adding negative 1. Technically we're adding negative 2. Technically we're adding negative 3. And so all I'm saying here is that even if you see x minus a number, it's still considered additive, okay? So x plus number, so x plus 1, x plus 2, easily additive. And it's just a little tougher here when you see the subtraction, but these are technically still an additive relationship, okay? And that concludes the video on what the constant does in additive relationships. Thank you.